Good afternoon, everyone, and welcome back from the lunch. Usually it happens that after the break, the audience goes like 50%, but I'm happy that didn't happen today. My name is Muriaru. I'm one of the account managers from the Global Services team. And today I would like to present, and I would like to discuss together with you about Internet of Things and how Internet of Things could be a motor of growth for LeaseWeb, for LeaseWeb partners, customers, and all the ecosystem that it's built around us. Oops. I have a technical issue? Oh, we don't have it? OK. Probably most of you have heard about this concept, about this paradigm of Internet of Things. But probably you are wondering yourself what really means. What's Internet of Things? What we are talking about? So first of all, Internet of Things is considered to be the third emerging wave in what is in Internet development. The first wave was like in 1990s, when the fixed broadband connection brought like 1 million devices connected together. In 2000s, almost because of mobile proliferation, there were another 2 billion devices that were connected. Nowadays, we are living in some times in which we expect like almost 28 billion devices to be connected until 2020, and this is a really big number. If it will be to define the Internet of Things and speak about the concept, probably we'll tell that it's a global and dynamic network with self-configurable capabilities, with defined standards and protocols where things, physically and virtually, could have identities, could have attributes, and could be able to communicate between one to the other using common interfaces. In order to be more clear, I prepared for you a small movie that I think that will be you will find exciting and could bring more value to my further presentation.
A flower will one day tell us where it was grown, how it was treated, or how it got here. Do you think it's possible to teach traffic to speak? Do you think a car can call an ambulance faster than a phone? Do you think it's possible for devices to automatically deliver important, often life-saving data to those in charge? Can you imagine an ambulance that gathers critical information before arriving at the hospital? And that a patient could be examined before he even enters the emergency room, saving precious time for the patient and his family. None of this is science fiction. It's all part of a concept that our team has been working on for several years, the Internet of Things.
In the movie that we just saw, we saw a few areas in which Internet of Things is going to have a big impact. We saw the services or the benefits that could be delivered to everything that is related to telemedicine and healthcare. And it's not only regarding the emergency services. think a little bit about the people that in this moment have like one general practitioner or a specialist like 100 square kilometers. This happens in a lot of countries. Think about the people that currently are living in very isolated places, where in this moment it's really hard to have a human connection, and they need advices regarding using telemedicine solutions. But it's more than that. Think about the benefits that could be bring into agriculture. There are places on Earth where it rains like 1 or 2 times per year, and it's really important to understand what is the temperature of the soil, how much water is going to need a certain plant, when should this kind of water should be inserted, and so on. So a lot of information that should be needed and could be delivered by the sensors and could be delivered through the Internet of Things. More than that, we speak about a connected city in which each of us would like to be able to use the efficiencies that the Internet of Things could deliver, starting from traffic intelligence systems, starting to synchronization between different transportation systems, and going to everything that is related to safety and security. More on that, if we are going to our homes, currently we are using separate intelligent devices that are not communicating between them, or communicate, but using on application or something. So things are already happening, and it's just, I don't know, in my opinion, it's just a matter of time until these things are going to be really connected, and we are going to be part of the Internet of Things. But let's speak a little bit about the components that are part of the Internet of Things. So first of all, on the base, there are the sensors. There are sensors that can take temperature, that can take pressure, that can take humidity. There are also appliances like smart TVs that probably most of you have already. There are smart fridges in the house. There are, I don't know, any other kind of smart device. There are always also health monitoring devices, like devices that in this moment can monitor your the number of your pulse, or your the level of oxygen from your blood, and could provide very useful information for a general practitioner. On top of that, there are the gateways. These sensors put together needs to communicate and needs to transmit basic information to a device in order to be able to make some kind of synchronization. Probably all of us, we are using in this moment, sorry. Oops. We are using in this moment smartphones. A new concept that it's coming, and it's really more important. It's related on systems on a chip, probably Raspberry Pi, Arduino, and of course, most probably, all of us have heard about the Nest. Do you know what is Nest, or did you? No. Okay, I'm going to try to make a short history about it. So Nest, actually, it's a company that was invented, like, I don't know, let's say in 2010, if I correctly remember, and it has like 2 or 3 products. The top-notch product that they delivered, it's a smart learning thermostat that it's able, based on our usual habits and based on the temperature that we set daily, to learn and to adapt based on it. What is more interesting is the fact that this company, in the moment before being sold to Google, had some revenues around 300 million. It was sold with $3.2 billion, so almost 10 times more. Probably you would ask yourself, why this happened. Okay, they had maybe a good product. They had some very talented software developers in-house. They have expertise and so on. But the difference is really big. If we dig a little bit more, we are going to find out that the person that invented and that was put at the base of this concept and of this company, it's called Tony Fadell. It's a guy that invented and was the head of what it was in 2001, the iPod platform. So actually Google didn't bought only a company. They bought a person that developed a platform that had a great success and had the mindset from Apple. So actually they were preparing, and they are preparing for a battle related to what could be the home automation, Internet of Everything, and what could be the impact of Internet of Everything related to mobile devices, to smartphones, and so on. And what is more interesting, before working for Apple, this guy worked like 4 years for Philips. So he was the guy that actually formed the mobile computing group in Philips, and he was responsible for Palm devices and so on. This happened between 2000. So it was a person that was here in this area, but history and future went to another part. Based on this gateway and the nodes, there are some services that we already see it, like emergency, like healthcare services, energy management, and home automation that are going to be built on top. The question that we should ask all of us is why it's happening now. Why the Internet of Things became such a trendy concept, why everyone wants to invest money, why everyone wants to be on the table on which it is decided how it's going to be standardized, what are going to be the protocols, and so on. There are a few answers that are really interesting to see and to analyze. First of all, we are speaking about the sensors. The sensors in the last 10 years became less cheaper than they were. So it's a difference, like if 10 years ago, the price of a sensor was like on average $1.30. In this moment, it's like $60 per sensor. So it's a really big decrease of price. Then there is the bandwidth. The bandwidth decreased in the last 10 years with almost like 40 times. So 40 times since in 10 years it decreased. More on that is the processing power. In the last 10 years, we are speaking about a decrease of price and increase of power of 60 times. So what was impossible 10 years ago because of the fact that the processing power was pretty expensive, the fact that we couldn't put a lot of transistors, a lot of microcontrollers, a lot of other electronic that should be on nanoscale in the same in one integrate. Now it is possible. More on that. It's really important, and we should be honest with ourselves and recognize that the smartphone proliferation was one impacted a lot everything that is related to Internet of Things, and could bring this into the value. In one weekend, Apple sold like 10 million pieces of the new iPhone gadget, which is a really important number. More on that. The internet connectivity, the wireless networks, and everything becomes more and more a commodity. We are able in this moment to use the public and free Wi-Fi networks. There are a lot of efforts that are put in this direction in order to facilitate the using of broadband infrastructure in order to be able, for example, I don't know, if you are on the street or if you are in front of a magazine and there is a Wi-Fi connection that is not used, to be able to use it. On top of that, the Internet of Things, it's going to generate a lot of data that is unmanaged and unstructured. Nowadays, there are companies that are involving a lot of efforts in order to to understand how we can how we can structure this data, how we can analyze, and so on. And probably Maurits is going to discuss more about this. On top of this, I could say that another really important aspect is related to IPv6, and this is mostly because in this moment all the devices and all the equipment that are part of a network have a dual stack. There is no one on the market that could permit only to implement only IPv4. They are doing IP version 6 as well. And this is a natural, I don't know, something that is really natural. It's happening. It just needs some kind of a push forward one in order to be only on this. We spoke a little bit about the, I don't know, what is part of the Internet Exchange, what is composed. We spoke a little bit about what generated this proliferation and why this concept is so trendy, but I'd like to speak a little bit about how do we communicate into Internet of Things. So actually, in this moment, there are several standards that are available, starting from everything that is related, for example, RFID. So the RFID is not a new concept. It was invented and it was used starting from the late 1960s. But everything that is on top, everything that is related to wireless sensor networks that are using low power personal area networks, protocols like, for example, wireless, which actually in this moment, it's a protocol that it's meant to facilitate the communication between sensor and a central base using the non-used frequency from the broadcast TV signals. Or, I don't know, other mobile technologies that are evolving like 3G, 4G, LTE, and so on. All these are going to facilitate the communication between devices in the concept that is the Internet of Things. Communication protocols. We know in this moment we have the technology, but probably you are wondering, because most of the persons that are here in this room are really technical, what is really the protocol that it's used in order to communicate between devices? Actually, there is no single answer. There are more protocols that are developing in the same time, and the reason is very simple. The reason is that in this moment, there is no single protocol that could be considered as a standard and could be satisfy all the requirements that currently are on the market. Think a little bit about the following situations. Let's take an energy and utility company. Do you have any idea what is the biggest problem that a utility and energy company has in this moment? So and so. It's so and so, and let me tell you why. This is really good, indeed. So a lot of companies in this moment try to understand how can you use the new trends like, I don't know, energy that could be collected and made from solar energy, from wind energy, and so on, water, and so on, can be put together and inserted into the network. The problem that they have in this moment, they don't know how to make a balance between what they produce and what is consumed. So this is the main challenge that a company has in this moment. They really don't know, for example, if tomorrow in Amsterdam are going to be 30 degrees and everyone is going to use the air conditioners, if they have enough power, or could they have enough power to put in the network. And this is why they invest a lot of energy, and they are looking very, very close to this, because it's really important to know 1 day, 2 days, or 1 week before what could happen, and based on the existing data, they need to prepare. They have commitments. Yeah, we have, like, for example, LeaseWeb. We have the EvoSwitch data center. What will happen, for example, if an energy company couldn't be able to deliver us energy in order to alimentate our equipments? Think about this. It will be a real disaster for everyone. So this is why they are really interesting, and they go a lot into it and try to understand how this communication could be possible. One of the protocols that it's really used for this kind of advanced measuring infrastructure, everything that is related to smart grid, is the constrained application protocol. Actually, it's a protocol that it's built on top of UDP, and it's a protocol that allows communication between low power sensors, yeah, that can send only small chunks of data, and they don't really consume a lot of energy. Of course, it's mandatory to be controlled remotely. This kind of protocol is currently used in the distribution center facility. So probably every energy company that currently has done some steps in Internet of Things, it's using in the distribution area the constrained application protocol. The next one is RESTful HTTP, which is actually a pretty simple protocol. It's more for home automation and for large, low-scale networks. The main advantage is built on HTTP, and this means that it's really flexible. On the other side, it's not really rapid because the TCP connections in this kind of protocol are persistent, and this means latency. Another protocol, it's the MQTT, which is really pushed. And why this happens? It's probably you have heard, or maybe you know. For example, the Facebook Messenger uses this MQTT. Yeah, this is the protocol in the back. The advantage of this kind of protocol, it's that it uses a publisher-subscriber architecture. This means that we can send data, and only part of the sensors can, I don't know, if they are interested about the data that is pushed, can take it, can interpret it, and so on, and take a decision based on it. The big disadvantage is that in this moment, the protocol, how it is made, it sends everything that is related to password and so on in clear text. So it should be built something on top in order to be secure. And well, last but not the least is the XMPP, which is a protocol that was using in everything that was related to collaboration, to messaging, and so on. And it's an option that could be considered. And why it is considered? Yeah, why? Yeah, of course, but what you should take into consideration is the following. It has client authentication, it has a lot of security, so everything that these guys don't have, it has. So when
it's extensible to infinity,
exactly, so exactly. So everyone is building on top because it's really flexible. It's I don't know, a framework that could permit a lot of scalability. Of course, when you're going to have real-time networks, you cannot use it. But when you are going to, I don't know, it doesn't really matter if your response or your information goes in 10 seconds or in 1 minute or something, then this could be a real good protocol to use. Let's speak a little bit about the operating systems. One of the problems that currently all the producers are meeting, it's related to the fact that a real-time operating system or everything that is related to a sensor should have really small amount of resources. So we don't have too much flash, we don't have too much memory on a microcontroller and so on. And as a consequence, we should try to adapt. The Free University of Berlin decided to invest energy in this project, which is Riot OS, and it's really a nice project because they managed to build a microkernel in which they can provide network stack. They can provide support for real time, for multi-threading, and everything that is going to be done in a low footprint. On the other side, there is another approach that is the commercial approach that is currently pushed forward by the ARM. They announced 2 days ago that next year they are going to launch what is called the Embed operating system. It's going to be an operating system that is going to be delivered by, is going to be free, and it's going to be for the ARM architecture. Probably all of us know that our iPhones are using ARM architectures. So everything is based on ARM. It's really interesting. What they came on top, they are going to provide a server that is going to be like a backend server that is going to be able to communicate with the operating system in a very easy way in order to permit the development of application, development of integration with big data, the analytics, and so on. About application. There are 2 types of applications. They are the enterprise applications that are going to go into everything that is related to industry, and there are the personal applications. To the enterprise applications, there are going to be a lot of energy invested in the way you manage the communication between the devices, how to control, how you are going to secure this connection, how you are going to secure the data that is in the repositories, and how you are going to analyze and visualize the data. Currently, there are 2 concepts that are currently going on the market. There is the approach in which we collect the data from the sensors, and we say, okay, we are going to send them in the cloud. They are going to be analyzed. We are going to try to figure out what's happening there. We are trying to structure the data, and so on. There is a second approach that is proposed by Cisco. This approach is introduced a middle layer, and it's going to be, it's called fog computing. It's a new concept that it's on the market, let's say. Actually, what they want to do is the following. They have a router that currently is capable of having storage and computing power. There are going to be some blades. They have invested a lot of money in deploying a new operating system that has all the features of the Cisco EOS, which is Internet and Operating System that all the equipments are using. But on top of that, it has a Linux-based system that is meant to provide the interface and everything that is related to communicating with the sensor. So Cisco says the following. For real-time applications, we cannot afford to wait the time to send data of the sensor to the cloud to take a decision and go back. So we are going on the network edge. We provide this computing and storage facility in order to be able to take easy the decision. This is regarding enterprise. Let's speak a little bit about the consumer application. What is important to know about it is that in this moment, everything is related to context-based operating systems. And the players that are, the best positions are, of course, Apple and Google. What they want to develop, and it's happening already, just think about, probably all of us, we have a Gmail account. When you enter, you see that there are 3 categories. Without doing anything, our emails are going to, 99% of the time they are going in the correct category. So the intelligence is already there. So it's the algorithms and analysis, it's already present. So what they want to do now, they want to take it and put it on the operating systems in order to be able to give suggestions, to launch application based on your needs, and to try to make it a very useful, an indispensable tool for our lives. Constraints and challenges. Phew, this is a very important subject. Rolf, if you want to join. Yeah. Okay. Okay. I saw that he wants to join us to speak about security and privacy challenges. So it's really important to understand that in this moment, there are a lot of concerns regarding how the sensors are going to communicate between each other. Who is going to have the ownership of the data? Who is going to be able to access our data? Think about the fact that we are in a smart grid, and we are going to permit to our washing machine, in order to pay less for our energy, to be activated when the energy from the network is going to be, available, and it's going to be it's going to be very cheap. Yeah. In that moment, our energy company is going to have ownership over our data. How they are going to use those data, what will happen with them, is something that is not really well standardized and so on. Standardization, scalability, and operability, there are also concerns. All the big players are on the table. They try to push their story. They try to make the world to understand that their approach is the best, that their way of thinking is the one that is going to give it's going to bring forward the Internet of Things. And last but not least, it's regarding the fact that all the devices are really power-hungry devices. So ARM have developed his Cortex-M microcontrollers, which are something between microcontrollers and DSP, with the mindset to overcome this this issue in this moment. Probably in a few years it will be different. Because I'm over with the time, I hope that Rolf will permit me to speak a little bit about LeaseWeb, because this is actually why we are here in the technical summit. I think that LeaseWeb, in all this concept, should be considered a meeting point. Actually, think about our situation. We have like 70,000 clients worldwide. Part of them, we really know what they are doing. Some other part, we don't really know what they are doing, how their businesses are growing, what are their objectives, and so on. Think about the fact that we can offer them, I don't know, a platform in which every customer that we have could be available to bring their knowledge and know-how in order to share with the others. This could be one of the motor for growth. Like it was the previous presentation. The cost should be down. Okay, should go down. But there are ways to do it in an indirect way. It's not only direct way. We can help through our ecosystem of partners, of system integrators, of clients, to bring more value to everyone's business. I heard a few minutes ago about the legacy architecture and the fact that it's not really possible to try to go from a legacy architecture and to a new architecture based on cloud technology and web technology. This is true. The companies that are currently on the market are like 20, 30, 40 years old. They have really good architecture in place that are reliable. They invested a lot of money and so on. It's really impossible, or it will be really difficult for them just to shift, because the market and the trends are like this. They are going to do it, but it's going to be gradually. Taking this into consideration, I think we have a very good value proposition for this kind of companies. We are able to host both hybrid metal and bare metal, and also the cloud, in order to interconnect them and to be able to take the best benefits. So databases or any kind of data crunching application can run on bare metal. There is no problem. And if the applications that are already prepared to go on web, on the cloud, can be migrated progressively in order to have the all ecosystems. And most important, let's not forget what is for us, I don't know, maybe the most, I don't know, the biggest advantage that LeaseWeb has. We have a really great network. All the data that should be transmitted into the Internet of Things, we speak about, I don't know, hundreds, thousands of exabytes probably is going to be in the future. Needs reliable, need a good network in order to be transited from the endpoints, from the devices, from the sensors, and go to the cloud in order to be analyzed. Just 1 minute about the conclusion. It's really important to understand that Internet of Things, it's a concept that was born from everyone's wish in order to find new revenues for products by developing new products and services. So it's a concept that is going to bring benefits to all of us. We speak about productivity, we speak about the cost savings, and it's related to everything that is around us: work, energy, management, and so on. The fact that in this moment there is a lack of standardization and there are some privacy concerns could delay a little bit the proliferation of Internet of Things, but it's only up to us and only up to the people that are involved in this concept in order to make steps further on. I know that I am already late, like 10 minutes, probably, or something. But if you have any kind of